speak to this topic of these 4 key words here: data, analytics, GenAI, and standards. But first of all, I would like to just mention a few things about a protocol at my university. At my university, we pay a lot of attention to First Nations people and their knowledge, their culture, and we try to pay our respects to them in everything we do. And you can see a map on the bottom right-hand corner of this slide to show you the Darwin area. I'm actually the local people call this place Larrakia. The local people are Larrakia people. They are saltwater people, and this is the region in which I live. And just to give you a sense of that, this is how this place looks around sunset when I walk along the beach. So then, when Professor Ogata invited me to talk in this webinar series, he requested me to speak about these 4 things involving learning analytics. Any research I'm doing involving learning analytics, what's happening in my own university, perhaps speaking about generative AI and its impact, and also the topic of standardization. This was the request, and so I'm going to do my best in the 15 minutes or so that I have to respond to this request, although my response may be a little bit, it will not involve so much discussion about research itself. And so there's a couple of assumptions that I'm making here, and that is that the viewers of this webinar already know a lot about the theory and practice of learning analytics. So the question in my mind is, what perspective can I offer you that is interesting? The other assumption is that worldwide at the moment, academic communities are confronting the challenges and opportunities provided by generative AI, and that there's a paradigm shift in education underway as a consequence of this. We are only witnessing the early stages of this paradigm shift. And of course, in terms of expertise in learning analytics in Australia, there are very many well-known experts that are involved in the annual LAC conferences, people like Professor Dragan Jusevic, Shane Dawson and George Siemens, several others. There are many experts in Australia who can speak to the topic of learning analytics with much more insight and expertise than me. However, my research agenda is a little bit different, and it spans a range of different topics, and I'm going to talk to those today. I'm also going to just talk about my work as a lecturer in education and how I'm using learning analytics. The last piece of research that I did was some years ago, whereby I'm very interested in questions and student questions, how to scaffold student questions. And I got very interested a few years ago in how student questions can represent useful data. And so one of the papers that we worked on here with colleagues from Norway was about that very topic. But in my day-to-day work, I do a lot of teaching with people who are preparing to become teachers, school teachers. And so we use a system here at Charles Darwin University in the north of Australia that operates, we use the learning management system called Blackboard or Blackboard Ultra, and within that system we have a learning analytics dashboard. And the truth is that for me, The main issue, the main way that I like to use analytics is to get an indicator of student engagement. And this is just an example of how that looks. I'm sure most people are familiar with this kind of representation. Of course, there's a lot of other learner data in our system called LearnLine that we like to make use of. We look at the class performance data. We look at the Kaltura video analytics, Turnitin analytics associated with all the plagiarism scores or attempted plagiarism scores. We look at peer feedback data using a system called Feedback Fruits. And there's various other ways in which we can look at student data to inform our teaching and to improve our teaching. My colleague, Michael Sankey, has prepared this representation of the kind of technology-enhanced learning environment in which we are working. And you can see there that there are many systems that we need to bring together in a university context. We're not just using a learning management system, but we're using virtual conferencing tools. We're using ePortfolio and evidencing tools. We're using productivity and communication tools, content management systems, various other student management systems, and of course, we also make use of the open web, social media platforms, web apps, open educational resources. So there's lots of different kinds of systems that we need to have a real-world view about, and in terms of the data that's being produced, in terms of the data that students and lecturers engage with on a day-to-day basis. So really, we could describe this situation as being working within a highly data-fied environment. So then back to my actual response to Professor Ogata's request, then my discussion today is really focused on how I'm combining these research interests. Very interested in data and data literacy, analytics, GenAI standards, engagement. SOTL is the Scholarship of Teaching and Learning, digital frontiers, and sense making. But the thing that's bringing all these things together, the overarching theme within my research is this idea of questioning with and within the digital environment. And I make a distinction between these two words because often many people just regard the digital environment as a collection of tools that we can use and we can become very competent at using. But my view is that the digital environment has evolved to become quite complex, in which we, humans, are actually agents and tools ourselves in the production of data that is then collected and monetized. So then in terms of a recent academic paper that I've just produced, I'm getting ready to present next week in Brazil, in Recife, at the AIED conference. And we are looking at themes around pre-literacy and post-literacy, in particular in the context of working with First Nations people, where we're trying to deal with the biases of large language models that bring a bias against marginalized languages. And so we're very interested in the post-literate possibility of AI in education, of generative AI, in that the oral approach to engaging with computers may render the use of text-based literate systems not as necessary as has been. And so the other area that I'm working in at the moment is in the international IT standards development, and this idea of a digital technology ecosystem is one in which people use that term ecosystem a lot when we're talking about digital systems, combining them when we need to achieve interoperability. And so in this work, I like to promote the importance of standardized approaches and also the close relationship between standards and innovation. And so, many of you in the learning analytics field will have seen this diagram, all about the learner at the center and the tools and the activities and the importance of learning experience and learning activities. Some of you may not know that this specification, the X-API specification that's been around for many, many years, has recently, just late last year, become an IEEE approved standard, the first open source standard within IEEE doing such a thing. And of course, this is a wonderful vision about the promise of data-driven learning, and that is the big value proposition of learning analytics systems, deploying learning analytics within digital learning. Another example comes out of OneEdTech, formerly the IMS Global Learning Consortium. This idea of the customizable personal digital record, but something that's comprehensive, that brings together, that aggregates all learner data into just one record. So another example of the kind of thinking associated with this, with standards that are available as we continue to build the digital infrastructure that is supporting digital learning. But amongst this, we have all kinds of terminology challenges, and if we look at some of the recent terminology that's evolving here, we see all these kinds of terms, not just artificial intelligence, but artificial communication and artificial cognition, neuroadaptive learning, things like the learning fabric and the cybersecurity mesh. All these kinds of terms are emerging all the time within the IT domain, and they become quite a challenge at times. We even have terms such as data storytelling, quite common out there, and it's one thing to be able to adopt these new terms. It's another thing to actually agree on what they mean. An example of the standards that I've been involved in within the ISO world, the ISO and IEC JTC1 SC36 world, is this series of standards that we began producing way back in 2016, all around data interoperability. We continue to do work in that area. Here's an example of the original reference model that we produced within ISO, within SC36. Here's an example of one of the pages within that standard. Standards are really, they are just documents that have all these different kinds of elements in them. Standardized approaches to how we refer to systems and components within the systems and how things interact. So that's just another example of that. And at the moment, we are working on some advanced use cases for learning analytics. And if you are at all interested in standardization, I would encourage you to communicate with your local representative of the Japanese Industrial Standards Committee and to submit your use case, your innovative use case that might relate to using learning analytics that might inform the ongoing standardization work within some of these international committees. Here's an example of one of these use cases. This is what they look like. They're mostly just narratives, descriptions of how something might proceed. And I'm assuming that these slides will be shareable to each of you so you can read those in detail later. But in all of this, when I'm thinking about learning analytics, there are some questions that are arising, important questions that are arising for me. And of course, the data might tell a story, but the question in my mind is storytelling a science? What data might be missing? Can we trust the data? How should consent be managed? Who owns the data? Many of these questions you would be familiar with, and many of the questions that are arising now because of generative AI in this space are all to do with privacy and ethics and questions of data governance. What's the best model for us to deploy in terms of data governance, understanding the origins and the destinations of data? And all these questions demand that we then think about other things, other aspects of the standardization process. And if we're thinking just about privacy, for example, then we need to think about privacy impact statements and how to produce a standardized privacy impact statement. The more and more you look at standards, the more and more you will find that there are standardized procedures for producing standardized data that can inform the way that we build and design systems going forward. So then here's a question that is also on my mind at the frontiers of where we're at the moment. What are the disciplinary trajectories of data science and artificial intelligence? If we think about the history of science and the history of evolutionary branching of science, all the subfields of science, and if we take, for example, artificial intelligence as a subfield of computer science that's been around for 70 years, we can possibly make a mistake to think that artificial intelligence is just a subfield of computer science. We could make a mistake that data science is just a subfield of information science. But my view is that we're at a point, at an inflection point at the moment that requires we take an interdisciplinary view of these things, because artificial intelligence now requires us to be considering public policy. It requires us to be considering ethics. So it requires us to do due diligence on a whole range of other considerations as we design and deploy systems. On data governance itself, we can say that the origins and destinations of data flows are complex. And that, as I said before, human beings are also agents. We're tools of data production, data that's monetized by big tech. Lots of issues about this. And so the ownership of personal data is contestable, and this is why we've got privacy laws such as GDPR coming out of Europe. But then if we're really going to deploy a data governance framework and a standardized data governance framework, we need to be able to specify things like rules and roles and responsibilities, and then policies to ensure privacy, security, and data quality, and in a context where all these things are managed safely, ethically, and responsibly. And so all those requirements aren't just technical matters. they are not just technical matters. So my point here is that interdisciplinarity is an increasing requirement on all of us as academics in this field, where we're designing and deploying systems that support digital learning as we move into the future. So then, when we think about the possibilities of AI, in my teaching, I often try to talk about the importance of having an historical perspective on the web, and I talk about the three main technologies that define the web since it was first built, and really the three technologies are all around search, social, and smart. We can think of these technologies historically, but they also running together, because we've been talking about smartphones and smart systems for a long time. We've been talking about social media for a long time, but all these different kinds of technologies, as stable as they are and as pivotal as they are within the web, are all about to change as a consequence of AI. And my view on this, in wrapping up this short session, is that the digital ecosystems that we're building, that we're engaging with and within, are increasingly complex. The digital environment itself is much more than a collection of tools, much more than a collection of tools. And the data does not just speak for itself. The instruments that we use to produce the data require scrutiny. We may be collecting data that does not actually render an accurate story. So we have to be very careful about that. I also think that the text production has become quite trivial. GenAI has made it so, and the corollary of this is that data production itself is also quite trivial. And this raises concerns about validity around the existing learning analytics systems that we have in place. And then the paradigm shift that I see that's underway in education is all about the evolution of an artificial intelligence-driven web, a dialogic web that's built around interaction and conversational agents, in which we move beyond the search paradigm of inquiry. It's a paradigm that's becoming post-literate, in a sense, in that we are going to be able to make use of other ways in which we communicate with computer agents to help us in the co-production of knowledge. This idea of human-computer collaboration rather than human-computer interaction. We're actually collaborating with computers to co-produce knowledge into the future. So then as a consequence of all of this, we're going to need an update to the conceptual frameworks that inform the way that we design and develop systems that support us. So then that's all I have to say today on this topic, trying to bring together these various topics, why they're important to me, and my commentary on all of this at the moment. So thank you for your attention, and thank you very much, Professor Ogata, for inviting me to speak during this webinar series.